Hey guys, so I've had a couple questions about how my batteries are wired with the BMSs and how they're combined in the DC load center. So I just wanted to show you a little bit about how it's done. So this is my battery here. I have 6 Volvo LG Chem modules that I got from Battery Hookup. And then I also have 3 of these ForTwo modules, and each one of them's broken in half. I bought this on eBay about a year and a half ago. It was a little bit more expensive than we're paying now for lithium, but it's been a great battery. Had very few cycles on it, and I've got no issues with any balancing or anything on it. So this is how I've wired it, and on each one I have a Daly BMS. These are 40 amp 16S BMSs, and the reason I've gone with 40 amp is because they're MOSFET based BMSs, so they don't take surges well, and they don't like being over clocked. And the way these are hooked up is the positive lead goes right onto the positive terminal, the negative lead goes to the BMS, and then out of the BMS it goes to the negative side of the breaker. Now, as far as these BMSs go, they aren't fancy by any means. They do their job though. They provide overcurrent protection, they provide over voltage protection on a cell level, and under voltage protection. I believe there's a couple other things in there as well, but that's mainly what I'm using them for. I have had one of these shut off with one of the cells that was a little bit lower than the rest of them when I was doing a capacity test. And it shut right off, and then I put a charge on it and it turned right back on again once the voltage was where it wanted to be. As far as balancing goes with these BMSs, they are not active balancers. They have 30 milliamp bleed resistors on them, and so they bleed off power on each cell that's gotten too high if it needs to, and they only balance above, I believe it's 4.15 volts per cell. So with my system, I can't even use the balance function on it, nor do I need to. Right now I have one cell out of all of these that is a little bit lower than the rest of them. I'm going to manually balance that with a power supply, but it's been fine. And I've soldered each one of these leads on, the voltage sense leads. There was a little tab there, and I've soldered each one of them on. They stuck pretty well. I did have to scrape them off a little bit, but they did stick pretty well. And so then everything goes into my DC load center, which I'll show you now. This is the DC load center, and I have 12 2-pole 20 amp breakers in here. And what I'd have is the positive and negative from each battery going into one 20 amp breaker. That allows you to do 125 volts through each one of these breakers. They are dual rated for DC voltage. If you look on Schneider's website, there is a white paper on that. It's not marked on the breakers, it's not marked on the load center, but it is rated for it. On the output of the combined batteries here, I have a 100 amp shunt. This was just put there so I could test the capacity of the battery. If I were to get one that was specifically for this system, I would get one that was rated for more than 100 amps. 100 amps is the maximum I can pull with my inverter right now, but this shunt does get very hot when it's at 100 amps. So I would get something that was rated for at least 200. Now, I did a capacity test on this whole thing the other day, and I came out with around 24 kilowatt hours of storage. So, and that was not going up all the way to the maximum voltage or all the way down to the minimum voltage. I kept it at about 64 volts maximum and down to 51 volts on the low side. Thanks for watching, guys. I hope you enjoyed the video. If you have any questions or comments, just leave them below, and if you like what you see, just hit subscribe. Thanks.